Got the answer?
Doing.
Okay, okay. You got the height reached. That's the first part, no?
Yeah.
How much is it?
25 meter per second. Now they are given acceleration of minus 10 meter per second. Time acceleration. Let's go to this question.
They are taken as 10 from
Yeah.
A to B. What is the height? You can do by energy conservation, no? Energy at
Yeah.
E 20. So half of 20.
Vertically 20 meter per second. Now
Yeah,
we can use v square minus u square to s from.
that is the same thing.
Velocity is 100 meter per second. Final velocity.
That's not required. Is it required? No.
How high will the ball raise? They
See,
ask.
once you get the height, no. You know the S for coming down. So S equal to ut plus half at square. That will give me the time.
Yeah.
Time to go from the maximum height point to ground. S equal to ut plus half at square. U is 0 from this for this downward motion. So just half E is 10 and then T square is the second coming down time. And S is 45. 5 T2 square. So T2 is 3 seconds. And going up time is V equal to U plus 80. I can use that. V is 0 and then U is 20 minus 10 T1. So T1 is 2 seconds. So total time is 5 seconds. 5
Well,
seconds. Yeah,
can
5
I?
seconds.
Can I? Yeah. Sorry.
You're making some mistakes then. Okay. So, okay.
I
Instead
took
of,
yeah, I took the 20s plus. I used
yeah,
the exact formula. I took
see,
20s plus.
one more way to do is I can find the total time. For that, I have to choose my origin of the x-axis away. I'll choose this as origin. I can also say the bottom point as origin. Okay, I'll choose this as origin for my y-axis or y1 axis. So with this thing, the displacement, the final displacement is minus 25. Upper direction is positive. So it's equal to ut. U is plus 20. This t is the total time. Minus half 10 t square. I'm writing this equation between this initial point A and this point C. So displacement in A and G is minus 25. Okay, and the initial velocity is 20 upwards. And then acceleration is 10 downwards as minus half. So this will become 5t square minus 20 t minus 25 equal to 0. That is t square minus 4t minus 5 equal to 0. Some mistake is there. So this is minus 5 and split into factor should give me minus 4. So it's minus 5, 1. So t minus 5 into t plus 1 equal to 0. T cannot be negative. So the answer is t equal to 5. So this problem can be solved part by part like T1, T2, or I can take the full time by choosing the appropriate coordinate axis. Okay, that's they put a second method.
Yeah.
First method is part by part. T1, 2 seconds, T2, 3 seconds. Okay. Second method, the total time in one go. So instead of taking this point as origin, I can also take the ground as origin. So in that case, I have to use S equal to S naught plus ut plus half at square. So it will look like this: y equal to y naught plus ut plus half at square. So the initial y naught is 25, and the final y with respect to this new coordinate system is 0. Okay, and u naught is plus 20, acceleration is minus 10. So this is clear.
Yes, sir.
Mic is off. So yeah, whatever you do it consistently with that.
Okay.
Okay, so I think the straight line motion, it's done. Okay,
Yeah.
unless you have some doubts, you can do it next time.
Okay.
So now motion in plane. So first thing you have to understand what is a scalar and vector. That is the first, because for 1D motion, I can take the direction by using the sign. But for 2D motion, I cannot, I mean, sign is not enough because there are multiple directions. So in 1D motion, the number of directions are two. One is the positive, one is the negative. But in 2D motion, how many directions are possible?
In 2D motion to two directions.
No, infinite. See, this is the plane of the screen I can consider as 2D. So I can move in this direction,
Okay.
move like this, move like this, move like this.
So n number of directions.
Infinite.
Yeah.
Okay. So obviously I cannot take one as positive, other as negative. There will be more than two possibilities. So I need this concept of vectors. Okay. So this specific direction I can say the angle theta in what direction I'm going. Okay. And also with what speed I'm going. So vector, I have to mention the direction and also the magnitude. So suppose this is 2 meters per second. The vector of parallel to this, but double the length, will correspond to a speed of how much?
Correspond to
Double the length. So it will be 4.
double the speed. Yeah.
Yeah. So suppose I have a direction, the opposite direction of the same length, then this speed is how much? Minus 2. Okay. Scalar is a thing which does not have direction, does not matter. For example, of scalar is volume. Volume does not have direction, does not make sense. Say this volume of water, there is nothing like direction to this. Similarly, mass of an object, that also is a scalar because there is no direction. Okay. But suppose I consider force, say the book on a table. So if we push this book from the left side with F1 force, then the book will move towards right. Okay. Suppose I apply the same F1, same value. See, this is 5 Newton. Same 5 Newton, but I change the direction to left. This is F2. Then the outcome is different. It will move towards left. F3, I'm applying downwards. Then in the case, rest. 3 is rest. It cannot move, right? But suppose I apply this upwards, then the book will move up. Similarly, if I apply a force in this, what is the direction? It's into the plane of this screen. Okay. And this dot is out of the plane of the screen. There are two possibilities. No, one I can get into the screen. Second possibility is come out of the screen. Okay. So getting into the screen is cross because if you assume an arrow, it will look like this. Back will look like somewhat like this. Okay. I have to draw it properly. Understood? No. So from the front, if I look, if I look this arrow from the front side, I'll need to look like a point. Okay. If I look the arrow from the back side, it'll look like cross. Okay. So if I put cross direction, it's going inside. Arrow is going inside. So the dot direction is arrow is coming outside. So in the first case, the force is inwards, the book will move inwards. In the second case, the arrow is coming out, the force is coming out, so the book will come out of the screen towards me. Okay. So similarly, if I say north direction, usually north direction is upwards.
Yeah.
You can assume India map. Kashmir is in the top, so that is north. Chennai is in the south, and east we have West Bengal, and west we have Maharashtra or Bombay. Okay, so if force is applied in the north, the thing will move towards north. So this also I can do with the one way of specifying the direction. And scalar we represent by an alphabet, vector by a alphabet with a bar or a euro mark on top, or we can make it boldface. This is for printed material. But for writing on pen and paper, we just put a bar or a arrow mark on top. Just to mention, it has got a direction. Example of scalar is temperature, pressure. Vector is force.
Yes, sir.
Okay, so vectors, what they have come, addition of vectors they have come. Have they taught addition of vectors?
Vector algebra.
Before that, yeah. First, multiplying a vector by a real number. So vector is represented by a arrow mark with a length, particular length. So this is a vector, say E. So lambda times E, how will it look? It will be parallel to A. That's the first thing. Okay. So one possibility is it's like this. Second possibility is for lambda is this much. What is the difference between these two? Suppose this is lambda 1 A and this is lambda 2 E. Third vector. So what is lambda 1 and lambda 2?
Vectors.
No, no. Can you compare with 1? More than 1, less
Yeah,
than 1?
yeah.
Lambda 1 is what? Less than 1,
Less
right?
than one.
Because it's fraction of A length.
Yeah.
And lambda 2 is more than, so the lambda 2 is greater than 1. Okay. And what about this vector? Suppose lambda 3 is like this. What can I say about lambda 3? Mic is off. What can you say about lambda 3? Your mic is off.
Lambda 3. Lambda 3 is in the negative direction.
So lambda 3 is negative. Another thing is it can be less than 0 but greater than -1. In that case, lambda 3, the length will be less than this one. But if it is like this, lambda 4a, then lambda 4 is less than -1. Okay, it can be -2. Okay, so the direction is reverse and the length is more. Is that clear?
Yes, sir.
So these are the different possibilities for multiplying the vector by a real number. Lambda is a real number. Okay, so next thing is if I have two vectors, suppose there is a block here. On a surface, if you apply a force of 5 Newton, it will move towards right. And suppose the 5 Newton is able to overcome the friction, it will move towards right. But suppose I apply a another 5 Newton like this, then what will happen? It will not move because the net force is 0. But suppose instead of 5, if I have 5 like this towards right, but from the left I have less force, 3 Newton. In this case, it will move towards left with a force of net force of 2 Newton. And if this force is greater than the friction force, then it will start moving towards left. Okay. So one thing we can, but suppose 5 and 3 are in the same direction. Then the net force is 8 Newton. So it will move with the effect of 8 Newton force. Okay. So here in this case, both are getting added up. Here in this case, they're both getting subtracted. So these are two extreme cases, but suppose a 5 Newton force is, say, horizontal, but 3 Newton is at an angle. Then the resultant force will be somewhere between 5 and 3. Okay. So it could
Yeah.
be maybe 3.5 or 4, whatever. Between 3 and 5 it will be. So how to add these two vectors where the direction is not 0 or 180 degrees? That's why we need the vector law of addition. So here there are two vectors A and B. Okay. One way to add them, the rule for adding them is this. Second vector you move in such a way that the tail will touch the head. Okay.
Yeah.
So the resultant is the tail of the first one to the head of the second one. One way
Second
to
one.
remember this is I can reach from this initial point. Let me call this
Sir,
initial
can I
point.
just turn off my video for a minute? I'll be
Okay.
back.
Yeah, yeah.
Yeah, I'm back, sir. We can
Yeah, I know.
continue.
So I can remember this like this. I'm going from this initial point to the final point by two ways. One is through A and B. Okay. Another thing is through this R. Both should be effectively same. So R equal to A plus B. Understood? Okay. So from this I can say the length of R, maximum length R can have is A plus B. Length of R, that is, I have to represent as magnitude. This maximum length is length of A plus length of B. That will happen when A and B are like this. A is like this, B is like this. Then R is this one. In this case, R will have the maximum value. The thing which I'm free to change is the theta. Theta I'm free to change, say for a particular condition. Okay. So when theta is 180 degrees, R will have the maximum value. Okay. So R will have the minimum value when it's like this. A is like this, but B is in the opposite direction. So in this case, R, the length, minimum values A minus B, and I can take the second one because if length of A is more, it will be positive. If length of B is more, means this will be negative, but it's considering the magnitude. Is this clear? Yes. R max is A plus B, R minimum is A minus B, and then I have to take the magnitude again. Clear? Is it clear?
Yes, sir. Yes,
Ah.
sir.
So once I know how to add two vectors, I can add three vectors. What is the logic? Suppose I know how to add A and B. Same thing I can use to add A plus B plus C. What is the logic here? See, A plus B plus C. How to add three vectors. Since I know how to add two vectors, first I'll add these two and get the sum as, okay, uh, let me call it D. Let me call this as D. Okay. So once I know D, I know how to add two vectors. We'll add C and D. So I'm doing step by step. Since I know how to add two vectors, I'll add two vectors at a time. First is add A and B, get a single vector D, and then add D and C to get a second single vector. Okay. So in that case, suppose A is like this and B is some other direction, and then C is like this. So A plus B will look like this by triangle law. So A plus B plus C will look like this. So from this I can get the polygon law of addition saying that tail of the B vector touch the head of the first vector A, and the tail of the C vector make it touch the head of the B vector. So this is forming an open polygon. So you choose the initial point of the first one, tail of the first vector, and the head of the last vector, join them, that will be the resultant. So this I can extend to n vectors. These are 4 vectors, A, B, C, D. I can move vector parallelly. So B I can move parallel to make the tail touch the head of this one. Similarly, I can move C parallel to make tail of C touch the head of this one, and D vector also like this. So here in this case there are 4 vecters. Obviously it will be an open polygon. So I can I can reach the final point from this initial point directly like this. So this and this A plus B plus C plus D should be seen. So this is polygon law of addition. Okay. And one more thing, this vectors need not be in the same. This particular example, they are in the same plane, which is the plane of the screen. These are called coplanar vectors. Coplanar means same plane. But the D vector can also be out of the screen. Then also the same law is valid. Just the polygon won't be a plane polygon, it will be a distorted polygon. I can pull this D vector outside, no, out of the plane of this screen. Still the law is valid. Is that clear?
Yeah.
Okay, it will be take a plane polygon and then just distort it. It will come out of the plane. Similar to parallelogram law, triangle law, we can also have parallelogram law. So there we made the tail of one touch the head of the second one. But here we make both the tails touch each other. So the tail of A and tail of B will touch. Okay, and then we can complete the parallelogram with A and B as the sides. So the diagonal which is between this A and B, that is the resultant. So this is similar to, same as triangle law, because this vector here is nothing but A vector. So in this triangle, if I apply triangle law, I'll get R equal to A plus B. So triangle law and parallelogram law are equivalent. Okay, in triangle law, you have to make head and tail touch. In parallelogram law, you have to make the tails touch. And the diagonal within the two vectors is the sum. So in this case, here the angle between A and B is acute. Second possibility is it can be obtuse. So A like this, B like this. Then also can complete the parallelogram. Okay. So this is the diagonal. So again, I have to draw the diagonal between the two vectors. So this is C. This is C. Okay. So here in this case, the diagonal is here in this case, R is the size of R is greater than A and also greater than B. Okay. Here in this case, it could be it could be less than one of them.
Yeah. Yeah, it can.
It could be less than B, but
More.
greater than A. That's possible.
Yeah. Yeah.
Okay. Another thing is, okay, forget this one. Just take this acute angle itself. This other diagonal, there are two diagonals, no? The diagonal which is between these two corresponds to A plus B, and this diagonal correspond to A minus B. If I take this as the direction, with this direction, in this direction. That you can figure out, right?
Yeah.
Because A is this one, I can reverse the direction. So B vector will be like this. The vector from
Yeah.
here to here is minus B. Okay. I think I made a mistake. This is minus A plus B. Because for this thing, this is the initial point. And this is the final point. So I'm going from initial point to two ways. One is this one. So other is through minus a. I have to take minus a. Okay. So this diagonal is minus a plus b. So this diagonal, the opposite one, this is a minus b. Is that clear? Because in this second case, this is my initial point, I2, and this is my final point, F2. So to go from I2 to F2, I have to reverse B. A direction is fine. Is that clear?
Yes, sir.
Or should I explain again?
That's okay. I understood.
Okay. So once a parallelogram is complete, there are two diagonals. The diagonal which is between the two vectors is the sum. Okay. The other diagonal is the difference. That's what I explained here. A and B. So this diagonal which is between the two vectors is sum A plus B, and this is A minus B. So here A plus B is greater than A minus B, the lengthwise. Here in this particular example, A plus B, the size is greater than A minus B. Is it possible for A plus B less than A minus B? Second possibility, is this possible? The first
That
case is
is.
possible because the example I've shown here. Second case, is it possible A plus B less than being A minus B? It is possible. For that, you have to take obtuse angle. A like this, B like this. Complete the parallelogram. So there is A plus B here.
Yeah.
And the other diagonal is whatever, A minus B or A plus B. This is A minus B. So here in this case, length of A minus B is more than A plus B. Extreme case is this one. Suppose I have A like this, B like this. So here A plus B is obviously more than, okay, A plus B some value. But if we take the same A, but reverse direction of B,
Then
okay, actually this should be minus B. Okay, so this I'll take this as B.
okay.
So here in this case, A plus B is more than A minus B. Correct? No. Actually, the vectors are like this, A and B are like this. So A plus B will be less because they will subtract. And A minus B, this is A plus minus B. Both are in the same direction, so this will be more compared to A plus B. Correct? No. Here in the first case, the angle is 0 degrees, acute angle. Second case, the angle is 180 degrees, it's obtuse angle.
So speaking up
Sorry.
obtuse angle. Yeah.
The first one, I made a mistake. The first one, I should not mention the angle here.
Yeah.
I should just mention the angle here, which is 180 degrees, which is same as this one. So when it's 180, the difference will be more compared to the sum.
Yeah.
Negative over vector is just the vector, just reverse the direction. So result of n vectors forms a closed polygon, which suppose if it is possible, then the sum will be 0. Suppose I am having some 10 vectors. I have to transport the vectors to form a polygon. Say first vector, second vector, third vector, fourth vector, fifth vector, sixth, seven. Okay, all the vectors are like this, tail to head. tail and
Total
head.
7 vectors.
So suppose this is an open polygon, then the sum of 7 vectors is 0. But suppose I have an 8th vector like this, which makes the polygon closed, then the sum of the vectors is 0. Correct? Sum 1 to 7 is some value. But if you take the sum of 8 vectors, 1 to 8, then it will be 0 because it's forming a closed polygon. Because there is sum is the initial point and the final point, which are same. They're just touching each other. So the vector length is 0. So result of n vectors which form a closed polygon is 0 by polygon law of addition. Correct? Your mic is off.
It is correct, sir. Yes, sir.
Ah.
We can complete that by drawing the date vector.
Yeah, here in this case, the polygon is open. But suppose this d would have come here, then there is no resultant will have 0 length. So given two vectors A and B, directions on what is the maximum range of values the angle can take. So two vectors are like this, A and C, B. But this theta is variable. I'm not fixing it. So in that case, one extreme case is A and B are in the same direction. Other extreme case, both are in the opposite direction. So theta range is greater than 0 and less than 180. If it is more than 180, we can take the shorter angle. Suppose if it is like this, instead of the angle between A and B is this much, you should say the angle between these two is this one. You take the shorter angle. Is it clear? So the range is between 180 only, less than 180, not more than that. Not required
Yeah.
to say it's more than 180. Take the
Yes,
shorter
sir.
angle. So what did they do last in this vector addition they have done? Mic is off.
Yes, sir.
Vector, what they did in the last part? What they have done?
Addition and subtraction of vectors till that they completed.
What about multiplication?
They haven't started yet.
Yeah, that will do. That is not that's required later. So vectors you can multiply by two ways. Suppose two vectors are there. A and B. One possibility is I'll multiply such that the answer I get is a number, scalar. Okay. Another possibility is the answer I get is a vector. Okay. This is called A cross B, where the resultant is a vector. This is called dot product or scalar product, A dot B. So this is dot product. This is cross product. This also is called scalar product because the answer is a scalar. And this is called vector product because the answer is a vector. And this A dot B is defined as A into B into cos of the angle between them, cos theta. And this vector is defined as AB sine theta, and there is a direction. The direction is perpendicular to the plane formed by A and B. Suppose A is like this, and B is like this, and the direction here will be for A cross will be dot. Because the rule is from A to B, I have to rotate a screw. So then the screw will come out of the plane of the screen. Or I can use my thumb. All the four fingers should point in the direction A to B. So thumb will come out of the screen. Okay. So in this case, A cross B is dot direction. Okay. But B cross A will be cross direction. B cross A will be again AB sine theta, which is same as BA sine theta. But the direction will be cross. Because I have to rotate from B to A. So either I can rotate a screw or have a right hand thumb rule. The four fingers should point from B to A. In that case, the thumb will go inside the screen. That's cross direction. Is this clear? Your mic is off. Your mic is off.
Yeah. Yes,
So
sir.
two ways of multiplying. One will give me a scalar, other one vector.
Yeah.
Okay. This they will teach next.
Okay, sir.
Yeah. So we'll continue next. 2 minutes are left. So we'll continue next time. So any questions you have?
No,
Today is
not
what?
much.
Thursday. So next
Yes,
is on
yes.
Saturday.
Then Wednesday no class, right, sir?
Wednesday off, weekly off.
Oh, okay.
Monday, Thursday, Saturday.
Okay.
So today physics class was there. Obviously it was there.
Yeah, it was,
So
sir.
what about out of 720, how much did you get?
720 my total.
No, no. Out of 720, how much you got?
My total marks.
How much?
600, 685.
Okay. What is the highest in your class?
720 full mark.
Oh, next one.
Next one. Oh, yeah, 710.
Okay. What about Pallavaram branch?
Palaram branch, I think the highest score was like six. The highest score in the Palaram branch, they scored like, I think it was Harshan. He scored like 645.
Mm-hmm. Gayatri.
See, her name was in there.
Okay.
I saw Harshan's name last.